Hello and welcome to yet another installment of my chemistry tutorial videos. Today I will be reviewing chapter 7, and like my other videos I could go over everything, but for the sake of this video I will only be going over the effective nuclear charge. So if you're ready, then I'm ready. Let's begin. So before we can actually solve for the effective nuclear charge, we must understand first what it is, and essentially we can find out what it is through Coulomb's law. And essentially Coulomb's law is the strength of an interaction between two electrical charges, and that's the nucleus and the electron. But however, it does depend on both the magnitude of the charges and the distances between the two. Also, before we dive into solving for the effective nuclear charge, I must clarify a few things, and the one thing is that the forces increase as the nuclear charges increase, and it will decrease as the electrons move farther from the nucleus. At this point, you're probably asking yourself, well, how do I find the effective nuclear charge? And well, the effective nuclear charge is actually pretty easy to figure out. All you have to use is this equation that I have given you right here, which is Z with the underscore EFF, which stands for effective, and then it is equal to Z minus S, and Z in this equation is the atomic number, and S is a screening constant, which is close to the number of inner electrons. With that being said, it brings me to the first example, which is what is the effective nuclear charge of radon? Okay, so much like my other videos, I have provided a step-by-step process in order to get to the solution, but the only difference is in this video is that to save the time and to of course save your attention span, I have put the steps down and then also put the answers right under them. So here we go, let's begin. So let's start by going over the question again, and then it says, what is the effective nuclear charge of radon? So the first step is to locate the atomic number. And to save time, I have cut out part of the periodic table, which is the noble gases side, and that's provided here on the right. And so if you go down the list, you have helium, neon, argon, krypton, xenon, radon, and I don't know how to say that one. But so if you're looking at it, you see that radon is 86, and so that is its atomic number. Step 2 is to find the screening constant, and so that could be a little confusing, but in order to find the screening constant, we must first write out the electron configuration. And so the electron configuration of radon is 6p6, and s and p orbitals share the same size of 0.85. So since we have two of the sixes, and it was kind of confusing, but we have two of the sixes, so that must mean we have two 6p orbitals. So that means all we have to do is just add the 0.85 together, and that gives you 1.7 as a screening constant. Okay, and so the final step is step 3, and that is to solve. So after you have compiled all this information and recorded down your data, you would just plug it into the equation. So then it would read Z EFF is equal to 85 minus 1.7, and that comes out to be 83.3. So hopefully you enjoyed this video, and that is all I have for today. If you need any help, please let me know in the comment section below so that I can upload another video, or just simply to help you solve another homework problem. But again, that's all I have for today, and enjoy the rest of your day. Thank you.